Hi everyone, welcome to the stream, and today I'm going to talk a bit about C++, the references, pointers, and objects. As usual, I'm streaming on 3 different sources. Prior to which there were some questions about casting. So basically in C++, I will talk about casting in detail during the next session. But basically there are several types of casts. There is static cast, which is used for simple conversions, like from integer to double, or from base pointer, or from derived pointer to base pointer. I mean, by derived pointer, I mean a pointer to a derived. I pointed to an instance of a derived class. And you can use this static cast to cast from this pointer to a pointer to a base class. So like simple stuff like that can be done during compile time statically. Same thing. So dynamic cast works during a time, and it's used for down casting, so casting from pointer to a base class to a pointer to a derived class, which can be done during compile time. Has to be done during runtime, so hence the name dynamic cast. Then there is ccast, and if I remember, ccast does a bunch of different things. It's more powerful than ccast. For example, it can cast away constantness, but I'm not sure. It's quite rare when you have to cast away constantness. And then there is constcast, which can cast away constantness. Sometimes it's necessary, especially when you're dealing with broken APIs, but normally you should avoid casting away constantness. It's a very rare thing when you really need to cast away constants. Typically when you have some sort of broken API. Then there is reinterpret cast, and reinterpret cast, well, it works interestingly. Basically, it can take something like a binary data and just reinterpret it as some other data. So for example, it's kind of weird actually. For example, I think you can take a double and interpret it as a long, and it won't change binary data at all, so you will get a weird result. Sometimes it's necessary when you are dealing with, for example, buffer. So you have a buffer of characters that you read from disk or get from a network, and you know that this is an object, and you just interpret cast it as an object, or or you interpret cast to a pointer to an object. Although this is somewhat rare because normally you would use serialization, but sometimes interpret cast is necessary. What's next? So dynamic cast, static cast, interpret cast, constant cast. I talked a bit about C-style cast. I rarely use static cast because I can use C-cast. I like C-cast because it's more concise. So what's next? Then there is functional style cast, and some functional style cast looks like that. So you can write let's say you have double a equals to 42.5. Well, it's a bash, but let's present it C++ code. And you can write something like int x equals to, or you have a function like, you can do this, for example. You can do standard cout int a, which is sort of like functional style cast. Or function style cast. I don't know what's the proper term in English. So sometimes I write this instead of writing like C-style cast would look like that, and I don't know if actually would compile. Maybe you need to add braces here. So most of the time I use so whenever possible I use functional style cast because it's more short, more concise. Okay, so today I'm going to talk a bit about casts during the next session of Friday. It's really interesting. But today I promise to talk about pointers, references, and objects. As usual, I'm keeping chat on the side. Typecast. What's typecast? I mean, typecast is just a name from like it's just a name for every cast. So like static cast is a typecast. C-style cast is also a typecast. So I was actually trying to Google some rules for C-style typecasting because I never really bothered with trying to work. Yeah, but it's a typecast and it's called a function style cast. Let me check what's the proper name. C++ function typecast. I don't remember. Maybe it's functional style cast. Fun. Yeah, functional notation. Okay, functional style. Okay, I guess I was correct. So yeah, we'll talk about. Okay, let's talk about references. And before we start talking about references, let me just talk about memories. So before we start talking about all this fancy stuff like pointers, let's talk about memory. And computer memory, and if you don't know how RAM works, the best way to picture it would be to picture a huge array. And every cell in this array is has a size of 1 byte, right? So let's say we have a huge array, like megabytes or gigabytes. It's not really contiguous. It's only semi-contiguous, or continuous, but just picture an array. And basically, or it's better. Maybe it would be better to picture this array, but not every cell is accessible. Anyway, just picture an array, and in this array, every cell has a number, and this number is it is numbered, and every cell has this number. And this would be 42, 42nd, this is 43rd, 44th, 45th, 46th, 47th, 48th, 49th, 50, 51, 52, 53, 52nd, that's 53, 54, and so on. So this number called an address, alright? So basically, let's talk about integers, or let's talk about characters. Let me check questions. By the way, post your questions in chat. I will have to answer. Okay, let's talk about integers. Let's say we have an integer, and it has size of 4 typically. So it's 32 bits, and to store integer in a cell, we just take 4 cells and write something in it. So let's say we have an integer, integer x equals to, I don't know, let's say 97, right? So it gets written somewhere. Somehow, as memory gets allocated. There are different ways to allocate memory, but let's say, in this case, compiler does it for us. So if we create like int main function here, the compiler will allocate memory for us, and it will be allocated somewhere in the memory. I will not talk about stacks and heaps for now, just about addresses. So it allocates it, and it takes 4 cells, right? And it writes something there. And in this case, it will write something like 97 here, right? 0 here, 0 here, 0 here. So it literally takes 4 cells, writes something in it, and yeah, basically there is some stuff gets written. So now what is a pointer? And a pointer is like another variable that can hold an address. So we can have a pointer to an x, and it's denoted by like that. So there is a bit of trickery, but basically you use star to denote the pointer. It's actually part of the variable declaration, not type declaration, but whatever. I will talk about it a bit later. And you can use ampersand to take an address of this variable, right? So, and an address, just remember that address is a number. You take a number, this number, and it gets literally written as a number to some other location. So again, the computer allocates memory for us, and it may be allocated somewhere here, right? Maybe it will be something like 51s, right? So it literally has another. So it's like another variable that holds an address. So literally 47 gets written into 51, and the size of a pointer depends on your architecture. If you're using 32-bit machine, the size is going to be 4. If you're using like me, 64-bit machine, the size is going to be 8 bytes. So literally, so let's say the size of a pointer is 8. So literally 47 and 8 zeros get written. Oops, I guess I need to align it a bit better. Okay, 7 zeros. 1, 2, 3, 4, 5, 6, 7. 58. So this is a pointer, and pointer has a few different operations that you can use to forecasting. So you can literally get. You can actually literally print the value of the pointer, like the address of the variable. To do this, you just can do this. To print an integer address in decimal system, and if you want hexadecimal address, you can just print the pointer itself. But it will be hexadecimal. Oops, why did I do this? I'm going to show you the code. I'm going to execute this code. And what's now? So I have these pointers. You can dereference them to get the original value of x. So something like that will get you an original value of x. Prints 97. And you can actually change the contents of a variable by doing this. You can write this, and then you can print this, and it will print 401. And if you print x, it will also print 401. So the reference and pointers just returns the original value, but you can also assign to the same memory address. So it works really nicely. Um, so you can also have pointers to pointers, right? You can have here pointer to integer, right? And again, you can have you can take an address of x, and x is just like, but pointer x is just another variable which has an address, and well, its address is going to be 51. And again, compiler takes. Let me just denote that this is where x is stored. This is where x is stored. And by the way, if you have questions, just let me know, because maybe you have different questions. Shit, how much I missed with C? Not a lot. Especially if you understand pointers, you probably didn't miss anything. Again, a pointer x is just a variable is just like x. It just has some special operations like star. You can dereference it. But you also can take its address by prepending an ampersand here. So compiler can write it. For example, so it decides to allocate it here, somewhere in the memory, on the stack. So it will be pointer to x. And again, I will not write everything here. There is like 6 more zeros. And again, it is just another variable that just holds an address of another variable. So yeah, that's how it works. What do you mean by sound? But it's probably my call. So you can do this. Oh, okay. Okay, so here's pointers. Okay. So in C++, many things have an address, and you can take this address and you can assign it to another pointer. You can store it, and so then you can indirectly access things. Let me show a pointer demo. Actually, I should probably check Twitch more often. So yeah, let me know in chat if you have questions. I just stream and watch people code. There is chat which has no lag. I mean, not chat, but the stream. And I should probably check chat on YouTube just in case. Okay, pointer demo.cpp. Let's just copy that stuff. Let me prove that I'm not lying. Just include everything. Right, so, and it should compile just fine, I think. Pointer demo. What the hell? Oh, clan pointer demo.cpp. Let's try it one out. Did I lie to you? Yeah. So this line printed this. Well, typically the pointer addresses are large numbers, because like the first page, because of that. So yeah. Here's the hexadecimal value, which is typically a bit more convenient to read if you have experience. And this is like an actual integer value. Let me prove that. Yeah, okay, it's literally, and as you can see, both these lines printed 401. So there is this sort of interaction. One interesting thing about pointers is that they can be null. Right. So, by the way, let me print this pointer like an actual address of this variable. Like, sorry, no, not this variable. We can print an actual address of pointer x. We can then dereference it, and then we can dereference multiple times. Let's see what happens. Oops. All right. So this is the value of variable x. This is the address of variable x. And this is the address of variable pointer x, like of this variable. Like I mentioned, it's just a normal variable. It also has an address. So an interesting thing about pointers is that they can be null. So you can assign null to them, and basically null is used to show that points to nothing. Like it points to like nothing. So it didn't point to something. Let's print it. Again, I can print it just fine. Yeah, kind of black hole. You can't write it there though. Okay. So yeah, it says it has null value. What happens if we dereference it? You can try guessing. Right. And actually very bad things happen. So basically what happens is something called undefined behavior. And it means that, well, it means what it's, it literally means that the behavior of the program is undefined. It can do whatever it wants. It can, I don't know, crash. It can behave some weirdly, right? It can, I don't know, weird shit can happen. So generally, you should avoid undefined behavior at all costs. That never use undefined behavior, and it's serious business. Don't mess with it. Don't do things like that. Okay, well, what happens? My guess is there will be segmentation fault. Yes, I'm right. You can't reference null pointer because it points to literally nothing. But how to park pointer in a proper way without undefined behavior? What do you mean by parking pointer? First of all, pointer is just like normal variable. How do you park integer? Well, you do nothing about that. Oh, set to nothing. You can set it to null. It's a proper way to say that pointer points to nothing. You just never should never write. You should never dereference it. Yeah, you shouldn't dereference it. It's a cost that we pay. You should check for numbers. So, for example, you can write this. Pointer to pointer doesn't equal to null, and write not null. Yeah, if you want, yeah, you should check it before. You should never dereference it. Never dereference null pointers. Okay, but printing its value, just printing the value pointer. So if you difference it second time, it goes to this address, and it sees what's there, and it sees, well, there is 97. Why there are different addresses? What do you mean? Okay, so I printed. Okay, so Where is it? Okay, here's the demonstration. A pointer to x is a variable that holds some address. I'm interested in the out. Okay, here, right? So okay, so basically this is the address of pointer x. So this is the first line. The first number is the address of this variable of pointer x. The second number is the address of this variable, right? And the third number is just this variable value. And since these two values are separate, since these two variables are two completely unrelated things, they have different address. I mean, you can't really. I mean, they're well, they're different things, so yeah, they have different addresses. I hope this makes sense. Here's the example, right? So in this program, let's say we have this memory layout, right? So let's say we execute this line here. Yes, this is the imaginary memory. So it will just go there and print this thing, just an integer. So it will print 50, oops. Sorry, it will print basically this. I thought C++ uses something like cpater, null pointer, not C, no, C is null. Well, C++ 98 uses null just like C. Null pater is a thing from C++ 11, and well, I'm not going to go into the difference between null and null pointer. If I remember correctly, it was done to it was done to improve resolution of it was done to make choosing one of the overloaded function more intuitive. So why null pater? I can find this. What are the advantages of using null pater? So basically, yeah, here is the code, right? So here is two overloaded functions, and basically fnull. When you call fnull, this thing is called, but this is not very intuitive, right? You would expect this function to be called. So they created a special null pater thing, and if you call null pater, then you get this function. So here's that. But I'm more focused on C++ 98. Maybe that's a bad idea, but I mean C++ 9.11 has a lot of nice things. So yeah, I would say that null pater is more like. I would say that null pater isn't a big change. Definitely improve things in certain corner cases, but I never ran into an issue with just plain C-like nulls. Okay, so here's this thing about pointers. Hope this makes sense. That may be a bit tricky to learn. Okay, so what about Yeah, okay, I'm going to talk about references. And references are a bit like points. Oh, by the way, I forgot to talk about arrows. Okay, so pointers. And again, what's about classes? Can classes have can we have pointers to classes? Of course we can. Um, so we have like public something, it has int x, let's say it have a constructor. Like I mentioned, constructor is just a special function. Int x, and actually I'm going to use a initializer list. Okay, let's print something like this. Okay, this okay, let's print it like that. Yeah, can classes have pointers? Let's create full. And actually we are going to add 42 here. Okay, let's not add 42, let's add 7 here. So remember how we print data members in classes. So how do we print fields? We just add dot here, right? So this will print 7, okay? How can we have a pointers to class? Of course we can, and we can literally just create a full pointer by taking an address to full, right? Okay, we can't really do this. This won't compile because we can't just print every class, but we can print full pointer. Again, classes have some sort of memory layout. I'm not going to go into details on how C++ classes laid out in memory. It's a very interesting topic, but it's very advanced thing. Oh, so full pointer. We can do this, and again, it will be just some number that we can convert into when we need to declare class instances points. I mean full, and why. I can't understand why I need to use full, and what do you mean? Do you mean? I mean, it's not an instance of a class. Okay. Do you mean that why don't I combine this into one declaration? Or okay, I will explain. Okay, I will talk about new. I guess I should probably talk about new. Okay, so we can again convert it into unsigned long, and it's just a number, just an integer number. Right, so it has some value. So how do we print full x then? Well, we can do the simplest thing would be like to do this, which is going to look ugly. Okay, that is works. So again, this prints 7. So we reference a pointer, and then we can use dot syntax to get the value of this variable. And again, we can decide to update it. For example, we can print, we can, I don't know, write 9 here. Let's see if it's updated. Okay, again, 9. So, as you can see, this thing doesn't create a new object at all. It's just the same object. It's just a pointer to full. Doesn't create new object at all. But this syntax looks kind of ugly. So that's why C++ and C has a bit better syntax. So you can, instead of printing this, using a lot of braces, we can just use arrow syntax. So we can do this, which is literally the same thing as on the line 35. So line 35 and 37 are literally the same thing. They are equivalent to each other. So now we have this thing, and it again prints 2 zeros, right? Nothing changed. Again, we can update it using the same syntax. Can write 11 there. Again, let's print it, and it gets updated. And as you can see, we update foo using pointer to it, and foo gets updated. So this thing points to the existing object. It doesn't create a new object. It creates a pointer, which is a separate variable, but it kind of points to foo. I hope this makes sense. I guess I'm using the word points a lot. Maybe I should do this. Maybe I should do this in the title here. When I started the course, I made sure that I made sure to mention that. I can answer questions about Newer C++ too, although I don't have much experience using it, unfortunately. So what about this thing? Okay, a bit about how memory C++, how can memory allocation C++ work? So basically there is a stack, and stack is like a stack. It's used for function calls, and when you call a function and when you define variables in function, they get allocated on stack. And I wish I could. I think I should. Let me Google some pictures. I should have prepared some pictures. Stack C++. Maybe there are some pictures. Let's see. No, not that. Oh, okay. I'm not sure if there is a good picture of stack. I wonder if there is a simple way to explain it. Okay, so basically this. When this function or any other function exits, you can't use variables that were declared there. They will be destroyed. You should never access variables that were allocated on stack and after the function exited. When function is still didn't exit, so when function is still executed, you can access them just fine. But after the function returns something, you should never ever use things that are allocated. So let me create a function. Let me show what I mean. We have an add function here, and it's has some variable, right? You can return it, for example, or actually let it maybe it will be a void function. So let's not return anything. Again, so let's say we have a function bar that takes a pointer to integer, right? And it does something with it, like updates it. Well, we can't really do this. But we can do this. Okay, I can explain this. Let's call it. What the hell? Why it's not much in function to call bar? Oh, okay. We can create a pointer here. I will explain. Yeah, I will talk about this. Okay, this function takes pointer. It also can, I don't know, it can test it for nullness, for example, even if it's not null. Again, it's these are synthetic examples, but we can update it here. We can also write pattern is null. Right, so we can do. I probably can do. We can do this. Yes. Okay, let's call function full here. Oh, we already defined it. Let's call it func1. Let's call it func2. So let's rename it to func2. And yeah, let's call it. Okay. So in this case, it updated the pointer, and let's print it here, the value. Let's print it right here. Now, so as you can see, y here is 456. So as you can see, it was here 100. Then this function took a pointer to y, and it updated the variable y using the pointer to it. So it dereferenced it, and it updated it. So yeah, here it can take, like I mentioned, it can check for null pointers just fine. So it didn't. So it didn't execute this piece of code, which would lead to undefined behavior, and it executed this this branch, which is good for us. Okay, so what's now? Can we just return a pointer? So technically we can do this, right? So we can return a pointer to y. So we can get a pointer y pattern here. And we can actually update it, which would lead to undefined behavior, but oops, sorry, made a typo. We can actually update it, but this is undefined behavior. My point is, you shouldn't do this. Don't do this. Bad things may happen. My bet is you can still print it. I bet it will print 40. Right. Welcome to undefined behavior. My bet it still would work, but it's undefined behavior. Oh, yeah, actually it printed random crap. So yeah, as you can see, but this one worked. Just don't do this. You should never do this. You can do this, but it will lead to undefined behavior. So never do this. Again, the thing is because it's not fine to do this. When this function is executed, any pointer to a variable created within it is valid. But after it's exited, you should never use it. So now basically this is because there is a stack, right? Okay, I decided to let me draw it. So you have like this nice memory like another byte. So for example, this can be 100, this is 149, 442, and so on, right? So basically functions have to store y somewhere. So for example, this let's say main stuff is somewhere here, right? I'm not printing it, and func1 stuff will be here. Again, for example, y will be stuff. So for example, y will be printed here, will be there. And what was its value initially? So initially its value was for y100, so it will be 100, 0, 0, 0. So then there is a stack. So again, it's a piece of memory, but when function called, another function is called, it puts its all the necessary stuff that is necessary to execute it to the sort of like right after this thing, and it puts its stuff and like there is like all the data needs. For example, it puts its parameter there, which is just a pointer. The pointer here will be stored. Right, so it gets occupied. So here will be stored 400, which is value of this pointer, which is just coincidentally equal to the value of the y. So that are some of the, like in this imaginary situation, the address and the value of y is the same, but it isn't guaranteed to be this way. So, and when a function exits, this stuff is destroyed. The actual memory might not be freed. The actual values might not be written by zeros, for example. And so in this case, its value is just some random crap for some reason. And we will able to update this memory value. This is independent behavior, of course, but we're still kind of able to execute this code. It's not guaranteed that it's will work every time. And for example, if we call another function here, like we create func3. Okay, when we get func3, next time it's going to override this stuff. It's going to put its stuff on where func2 stuff was. So because that's how stack work. Now what about new? And sometimes you need to pass pointers to objects, and you need to then persist across them, like multiple functions. And sometimes you need to objects to be allocated not on stack, somewhere else. And the place called heap. And it's like a special thing. So this allocates memory on heap. It creates a completely different pointer to int. Actually, I don't remember the syntax for integers. I think it's just this. I might be wrong. Oh yeah, I remember it correctly. So it creates a new integer, and it returns a pointer to it. Like copy of. So it's a copy of an object, not the original pointer. And we can compare its values, by the way. Copy of y, right? Let's compare it to an actual value of y. So let's make sure that these are two different integers. By the way, let me know if it makes sense, because maybe I should explain it. The different way. Let's actually return it. Again, this is a perfectly valid C++, because we allocate this object on the heap instead of on the stack. So as you can see, the address of this variable and the address of this variable of like this object is different. And actually, it shouldn't print welcome to undefined behavior. So as you can may notice, it prints for 146 as it should, and it's no longer an undefined behavior. And well, now you can do this. So let me remove a variant here. Just let me know if it makes sense. I worry that I'm not explaining this clearly enough. So now what about references? Let's talk about references. Okay, until now everything makes sense for me. However, when is required dynamically created object, should we use smart pointers or raw pointers? Why? I would say that smart pointers and raw pointers are kind of different things. And smart pointers is kind of advanced topic, so I'm not going to go in. So if you don't know what smart pointers are, don't worry. But well, class Octave clearly knows what is a smart pointer, and I would say that typically you should use smart pointers because why not? Is there a reason not to use them? I mean, RAYY is a very nice thing. Yeah, it helps avoid memory leak because with raw pointers you have to call delete manually, and smart pointers call delete automatically in their destructors. There are different sorts of smart pointers like shared pointer, intrusive pointer, unique pointer, and depending on your situation, you should use one of them. I think there may be performance reasons to use raw pointers, but so there may be a performance penalty to using smart pointers. So sometimes if you have a good reason not to use them because of performance issues, then don't use them. But generally, intrusive pointers are fairly efficient. And I would be surprised to know that you can't have nice performance with intrusive pointers. Sometimes shared pointers are costly, but like mentioned, if shared pointers are too costly for you, use intrusive pointers. So yeah, resource allocation is initialization is a very nice thing, and I really like this idiom. It helps you avoid leaking. It helps you avoid memory leaks, and well, in other cases, it helps you avoid leaks of other resources, like for example, file descriptors. Okay, so now what about references? This short thing. Okay, I will. Well, references is an interesting thing. It's kind of like pointer, but it can be null. So, and you can't reassign them. So, I forgot to mention that you can reassign a pointer. So, for example, let's print something here. std and standard dandelion, and let's say we have for integer x and we have integer y. Actually, let's call them, I don't know, q and p. I think there is already integer x and y. So let's create something like and let's just call it t. and it's going to be null, right? So let's print it. Let's actually print the values of the addresses of Q and the address and P. So let's also print the address. Привет. Let's print the address of P. One day, what's wrong? Oh yeah, semicolon, missing semicolon. Again, we can reassign the pointers. So we can assign it to P, and let's print its value. Then we can may decide to reassign it to Q, to hold the address of Q, right? So here if you write 400 and Q gets modified here. So if we print Q here, 400 is going to be printed. Okay, so look at that. Originally, pointer is just a null pointer, but look at that. After we assigned the address of P, look at the value of pointer T, right? It's exact same as the value of P. After we assign it to the address of Q, it's the same as the address of Q. So I hope this makes sense. So you can change the address to which a pointer points. Now what about references? Well, references are kind of like pointers. You can use them. There are technical differences. There are some differences, but you can view references as being pretty similar to pointers. So what is reference? Okay, reference is kind of like pointer. Right, we can create a reference. The syntax is similar. Reference is denoted when it's required to modify an object variable inside a function. Should we prefer references or pointers? In that case, when is the pointer preferred over reference? Is it safer to use references over pointers? First of all, reference can be null. So this is the first difference between pointers. So in a way, it is safer to use pointers references, and I would say that typically you should use references because references are nicer. Okay, so we can have a reference to something. Let's have a reference to cool. Here's the syntax. Again, it's similar, and again, if we do this, we are going to create a new integer, like a copy of Q. Let me show you. Like int copy equals to Q, right? So let's print copy, reference, and Q. Okay, let's modify copy. Like 43. Okay, again, let's print it. Then let's modify the Q itself. It gets printed 45, and then let's modify reference. Again, look at that. The syntax is different. With pointers, we had to dereference it first, but with the references, we don't have to do that. So references are nicer. Okay, look at, oh shit. Let's add more spaces. Yeah. Oh yeah, look at that. Originally, everything like both copy, ref, and q they were like 100. When we modified copy, this copy became 43. And then we modified q, and as you can see, copy wasn't changed, and the references, and as you can see, when we access reference, we get 45, right? Again, when we modified this thing using a reference, again we get the same value in both ref and q. And the reason is that copy and reference, well, sorry, and the reason is that q is for the same thing. So reference and q are just like two different names for the same thing, right? For the same object. So let me check if there are questions. Let me know if there are questions, because I will be happy to answer them, explain everything in more depth. Another way to think about references as sort of as a special kind of pointer. Again, like I mentioned, we can't really reassign a pointer. There is no syntax for reassigning. Sorry, we can't really reassign reference. We can change what's the value of pointer, but we can do this with the reference. So again, think about references as a different name for the same thing. So why do we need reference, right? Well, the most common way of using references is for passing things to a function. Let's do this. Like, let's call it mega function, and it's going to take a reference to an integer. Like, oh, okay, let's not call it mega function. Let's call it something ref demo1, and let's call it ref demo, and let's call it copy demo. And ref demo is going to take an object, or it's going to take a reference to an integer, a copy. It's going to take a copy. Okay, what? Let's see this. Basically, we can just copy demo begins. Copy demo ends. Again, let's do the same thing for the ref demo and copy demo. Oops. Ref demo. Alright, what we can do is we can print x, modify it to something like, let's say, put the 1000. Okay, let's print it again. And well, yeah, this is it. Let's do the same thing here. Again, we have integer here. Like the only difference is this character called like this ampersand. Otherwise, the declarations of functions are very similar. And as you can see, they do pretty similar things. Now let's create a variable called n. Let's put 13 here. Is out main n. Let's print n here. Alright, so the print n here. Let's call copy demo. I don't know. Let's call copy demo here. Let's call function demo here. Oh, it was ref demo, I think. Oh, and we need to pass a variable here. Again, did it work? Okay, yes. Let's print a huge delimiter here. Okay, let's see that. Originally n is 13, then copy demo begins. Let's go over there. Again, it prints x, and x was 13, just like here. Then it's 1000. Then ref demo ends, but in main n is 13. And the reason is because x is a reference to n, right? One tiny character makes a lot of difference. So it's kind of a different name for the same variable. Oh, can we do the same thing with pointers? Yeah, we can actually. So we can do the similar thing with the pointer, right? Let's rename the function to pointer demo. So we have pointer demo here. Again, we take x. Again, we can't no longer have the similar syntax. Again, to get the value of x or the value of n. I mean, no, to get the value of n, we need to dereference x because x is a pointer. Again, here we have to dereference it. Again, we can print it, but x is just an address of n, and we need actual n, right? So yeah, and let's call pointer demo here. Pointer demo, right? What the hell? Oh, and we need to take an address, right? So we need to pass an address here. Okay. We can see here pointer demo begins. X is 1000 because it was modified in ref demo. Then n or star x is 3000. Pointer demo ends, and n is again 3000. Isn't there a reason to prefer pointers over references in this case, or references over pointers? I would say that there is a reason to prefer reference over pointers because it looks nicer. Look at that. There is no stars. So it looks a lot nicer. I'm pretty sure that the main reason we have references in C++ is to have this nice syntax for passing variables. So yeah, I would prefer definitely, in this case, I would definitely prefer ref demo function over pointer demo. And generally, unless you have a good reason, you should prefer reference syntax. Now, yeah, another important thing is we can accidentally call pointer demo with null. Well, we can't actually, sometimes, and we can't really do this with ref demo. There is no syntax, like absolutely no syntax to call this. You can't do this. It's not. It says that no matching function to call for demo because reference isn't pointer and we can't pass accidentally null here. Again, we can do this, but we shouldn't do this. This is undefined behavior. Dereferencing and null pointer is an undefined behavior, which typically leads to crash of the program. Segmentation fault 11 means that it was. Yeah, we should validate. If you have this, yeah, we should do this. So for example, here if x, so we can write this if not x, or we could write either if not x or x that isn't equal to null. We just write it on. Oops. Oh, wait a second. It was null demo. Sorry. We should do this here. Sorry, I was writing the correct code, but in the wrong function. Okay. So again, there won't be an undefined. What the hell? Oh, if x equals to 0, sorry. Obviously, if x equals to 0, and it works because we check for null pointers. Sometimes you need to, sometimes passing a null pointer is a, yeah, I mean, if you want to reassign the pointer, you may need to pass a pointer. But well, if you need to, we can't really reassign x here. But anyway, here we can't reassign it, but sometimes we need it. Well, in this case, ref_dem is preferable. So yeah. Ooh. Wow, it was longer than 1 hour. I was pretty sure that I will be able to explain everything in like 20 minutes. Oh, how many people are still there? 11 viewers. Wow, thanks for watching. Do you have questions about references and pointers? If so, let me know. And general C++ questions are also accepted, so your questions don't have to be related to. There is a recording on YouTube. So, are you streaming in 3 places at once? Yes, I'm streaming to 3 places in one. Error checker is called syntactic. Yes. So there will be a recording on YouTube, so you can watch it later. Here is it. If you have questions, you can ask me now. They don't have to be related to pointers, but yeah. And if I need to explain something again, let me know. I will be happy to do so. I'm pretty sure that I didn't explain everything like perfectly, especially to some people. It's just a fairly complicated topic. It didn't really get into casts, into I watch video on YouTube and test and repair. Yeah, that's totally okay. But if you have some questions now, just ask. I will be happy to answer to your private message though. I'm kind of tired, so I'm wondering if I should write Tetris. Like, please let me know in chat if you came from my live coding. Yeah, sure. Maybe you had some questions before watching the video. Like maybe you were learning C++ before the stream, and you were reading some book or some Stack Overflow question which wasn't really clear to you. And well, C++ is a fairly complicated language, so you'll be surprised if there is uncertainty. Okay. See you again. If you have specific questions or like semi-specific questions, again, let me know. I just love questions. So I'm wondering if I should start live coding or if I should end the stream. It's actually already there. You can rewind even right now. And right now you are able to rewind on YouTube. And when I end the stream, it will be available instantaneously or instantly. I don't know what's the difference between instantaneously and instantly. So just right after the stream, you will be able to see it. Okay, there is 9 viewers now. I guess people are tired. I'm tired too. So Tetris theme. Maybe I should do live coding. I don't know. Should I or shouldn't I? I'm a bit tired. Okay, next time. Okay, I will end the stream now. So next time I will explain different casts and how to use them. and now there are like 5 people on Twitch. I don't know. Whew. Okay, next time we will explain different casts like dynamic cast, static cast. Although maybe I should explain inheritance first. I don't know. So either casts or inheritance. I don't know. I will decide after the stream. And I will continue coding like the Tetris during the next session. And yeah. Now, if there are questions, please let me know. Otherwise, I will just add a countdown and I'll end the stream. So, random C++ questions or semi-random. So yeah, I'm not at its development here, guys. I'm just going to remove it. It took a lot longer to explain pointers versus references versus copying. So I hope that I will talk for like 20 minutes and then start to code Tetris for like an hour. But it took me an hour and a half to just explain things. So I'm waiting for another minute. Let me know if you need the code. I mean, it's pretty much just random stuff here. But if you need it, I can share. Test. Recently, I implemented red black tree binary search tree and would like to implement a graphic layer to actually see it. Could you recommend me a graphic library framework? I'm looking for something very basic. I would look. That depends. I mean, if you just want to know how to draw circles, you can use SFML. Like this is the library I'm using for developing the Tetris. It doesn't have special things for visualizing graphs, but it's just a nice multimedia library. You can draw circles in it. You can just write games in it, and I'm pretty sure you can write something basic. I mean, if you don't mind drawing circles, drawing lines, and drawing every connection all by yourself, that's a great library. That's just what you probably need. And then there is SDL, which is a similar library, but it's written in C, and I'm pretty sure there are C++ wrappers. but yeah, I kind of prefer SFML in C++. What's next? I mean, I'm pretty sure there are some libraries for graph visualization. Visualization. So maybe they will be better choice. I heard that I have a friend who worked on OGDF. Oh, then SFML probably great. It's probably great, but just you should probably be aware of other solutions like GraphViz. If I remember correctly, isn't C++ specific. It's just general graph visualization tool. Can't open it. My online friend participated in OGDF development during last summer, and I'm pretty sure it's a nice library too, although I never used this. I can't really comment about the other three libraries. Phew. Actually, I'm curious about it. Yeah, it has. I'm pretty sure it's a really powerful thing. So you don't have to draw all these connections, and it has some support. If I remember correctly, it's not C++ related. Wow, that looks cool. That looks cool. And it's just some. I'm actually interested in. Let me check it before I end the stream, or before I answer other questions. Well, apparently there is a really nice format. It's actually pretty cool. And you can change core color here. So if you generate some sort of code in this special format, you can use GraphViz to visualize it. And it might be simpler than writing your own visualization tool using SFML. But I don't know what you want. Maybe it's fun for you to implement your own. So I kind of thought I will talk about two possible options. Okay, 8 viewers. Let me start the timer. Since there was a question, I will wait some more. Where is that call? Coming down. Let's start it. Let's wait for 1 more minute. Maybe there are questions on YouTube? No. You are welcome. Oh. So the next session is on Friday at 7 p.m. I guess I will talk a bit about casts, or maybe inheritance, and then continue developing the Tetris. Alright. Time's up. No questions here. So thank you very much for watching. See you on Friday, and